Given that a is less than b, the function is positive for all x between a and b, the trapezium rule produces an overestimate for this integral for these statements. Which one is true? Now, the if statement means that the right-hand side is implying that we get an overestimate. Only if means us getting an overestimate implies that part of the statement. And then if and only if means they're implying each other. So this is our setup. Let's just have a look at when we would get an overestimate. If we have a positive gradient, then we can get an overestimate if the function is increasing. If I draw the trapezium quite far apart, you can see get these extra bits. Whereas if we had a positive gradient, but it was decreasing, that's actually when you get an underestimate. Let's just take a look at so let me just write down f of x greater than 0, f double dash x greater than 0 will get an overestimate. And here, I'm not even going to write that one down, but it's the opposite. And then what if I have a decreasing function, but it's the gradient's actually increasing like this? Actually, again, I'll also get an overestimate. So f dash x less than 0, but f double dash x greater than 0 will give an overestimate. As opposed to a decreasing function that's getting the second derivative is also less than 0 because the gradient is decreasing. So for this, I would get an underestimate. Okay, so we've got a bit of a feel for it. So certainly, us getting an overestimate does not imply that the derivative has to be greater than 0, because I found a situation where it's less than 0. So I can rule out b, and because of that, I can rule out c. And then for the other one, do I need us to have an overestimate to have the derivative less than 0? Well, again, I found an example where it's greater than 0, so I can rule out e, and therefore I can rule out the if and only if part. So we're looking at a or d here. So does the derivative greater than 0 and the second derivative less than 0 imply an overestimate? Well, actually, I've shown for this second one that it implies an underestimate. That was positive gradient, but second derivative less than 0. So A is wrong as well, which just leaves us with D. If the gradient is negative, but the second derivative is positive, will we get an overestimate? That is that example there. Yes, that one is true. So our answer is D.